My name is Dan Marriot. Just a little bit about me. I run a cloud architecture consulting practice with clients in Israel and all over the world. And with me, I have Sagi Grimberg, CTO of Lightbits.
Hey Dan, great to be here with you today, talking about storage and infrastructure. Should be great.
Looking forward.
Yeah.
Today, we'll talk about some of the challenges and opportunities that cloud service providers, enterprise private cloud, and public cloud customers face in 2022 and heading into the future. We're also going to talk about technologies that can help these players overcome these challenges. So specifically around storage.
Dan, we're seeing such a massive growth in data, right? And data processing with AI, ML, and analytics, which was there for a few years. And as companies invest more in their data, inevitably, network, compute, and obviously storage capacities increase dramatically, right? And if you're going to build infrastructure to support it, then this is exactly where considerations like cost, efficiency, scalability, they all come into play.
Absolutely. So you're 100% right. So let's just dive in. I've been building data centers and cloud infrastructure for over 20 years now. I've seen a wide variety of use cases, needs, and solutions. Since every business is unique, it's so critical to ensure that the specific business needs are really well understood by the architects before designing any solutions. And along with that, it's essential to understand the company's growth plans, yet also be able to be very agile when business conditions change, whether it's a pivot, whether it's an acquisition, or even a hyper-growth situation. And of course, all such architectural plans have to reflect the financial capabilities of the business in question. Okay, and perhaps today, more than ever, it's so critical to make the correct architectural choices for your business's cloud infrastructure, and also taking into account your team's technical knowledge.
Yeah, that's a great point. But how do you go about building solutions with your customers?
So our job as cloud architects is to enable the business to deliver great performance to the customer while handling scalability, security, and resilience in a manner that the company can actually afford. And a key responsibility that we architects have is to stay abreast of new technological developments and be able to exploit them so that your company can differentiate itself.
Yeah, that's important.
So one of the major challenges that I'm seeing these days is around storage, specifically handling huge, sometimes exponential growth in data, but also importantly, being able to have this data on really high performing storage infrastructure.
Yeah.
So Sagi, can you talk to some of the use cases that you've seen?
Well, if we look at, the cloud builders and the people that build the cloud, they include obviously cloud service providers and, edge cloud providers, enterprises building private cloud on-prem or on colo, and also telco companies. They all have different use cases, right? If we look at the cloud service providers, they're, selling compute, network, storage, and other services, and they compete with their value add, whether it should be price, performance, points of presence, etc. And edge cloud providers sort of fit into that category, but with different emphasis on footprint and whatnot.
Absolutely.
And enterprises that build internal cloud to support a set of internal applications that may or may not consist to one monolithic application like a website. While consumers are internal, the scale and variety of application and services that run in the data center today is so massive that enterprises are building a cloud infrastructure to support that in a scalable way, in a self-service model, so that they can actually achieve the goal, right? But Dan, you have clients in the telco industry, right? What sort of trends or challenges are you seeing when it comes to cloud?
Okay, so looking at the telco industry, the trends as I see it are 5G, IoT, Internet of Things, edge to cloud connectivity, and edge compute, along with the storage that supports the edge compute.
Yeah.
And in terms of challenges, there are definitely a few that I can think of. So firstly, US telcos serving government or military are undergoing massive transformation migration projects to both update their networks and also to replace Chinese manufactured network hardware that they have in place. And this was mandated by the federal government some years ago. And this is a huge challenge given the potential downtime involved and the complexity of their networks. By the way, also governments in European countries, from UK to Sweden, as well as Canada, Australia, New Zealand, have all, I believe, mandated various bans on Chinese network hardware, especially on their 5G networks. All of this requires costly and complex replacement programs, which requires a lot of analytics in order for them to handle these migration replacement programs efficiently.
Yeah, that makes sense.
It's a massive,
it's all over.
complex solution for them to accomplish. Second, due to the critically sensitive nature of telco's infrastructure data, highly secure and segmented data centers are often required, meaning that they can't use public cloud for such data. They have to keep it within their own private clouds. Thirdly, telcos need to ensure very low latency for some of their applications, clearly, because they're telcos and we depend on super low latency. Otherwise, things like voice can be seriously impacted. So that requires metro data centers or micro-pops in areas of especially high density populations, translating into the need for ultra high performing, low latency compute and network storage. So, actually in a number of ways, telcos share a lot of challenges that are similar to that CSPs and enterprise private clouds also require in this context.
Well, that makes a lot of sense. There's obviously a need for scalable performance storage in the cloud, but in your mind, what else is needed then?
Well, managing this growth, Sagi, also puts pressure on maintaining standardization across the CSPs or enterprises infrastructure. Yet, standardization is critical if you want to preserve what I call the 6 pillars. That's reliability, scalability, performance, security, cost effectiveness, and manageability. Okay, so how do we address the growing appetite for storage performance? We know the ultimate in storage performance is local, right? Either memory, insanely expensive, or local NVMe drives. Of course, both have that critical limitation of being local, with the expensive flash essentially being stranded or often underutilized because there's no native sharing. So next down the performance chain are SANs, storage area networks. However, there's a big performance gap, even when using fiber channel, let alone iSCSI. So what we're looking for is the holy grail of local NVMe level storage performance, shared over standard networks, and that uses commodity hardware.
That makes sense.
So, Sagi, what are some of the essential attributes of a storage system that can address these needs?
When we look at a storage system that can address, some of the needs and the cloud needs that you laid out, we need to look into several, aspects, right? Number one, high availability, right?
Absolutely.
This must be enterprise class. It cannot usually work, right? Data needs to be always available during failures, during maintenance, always with great performance and QoS, right? Number two, efficiency or storage efficiency, right? When we talk about the innovations that SAN has introduced in the past 4 decades, today it translates to significant cost savings because data is expanding always, right? So this is sort of a must-have in this day and age.
100%.
And that leads us to sort of a different aspect of efficiency, right? The ability to support dense hardware configs, with hundreds of terabytes and more in capacity in every single enclosure, and being able to scale horizontally. So we can get a massive storage system that can serve a lot of individual workloads, right?
Yep.
Number 3, security, right? Whether the environment is shared or dedicated, data needs to be encrypted, and every access to the storage system needs to be authenticated and authorized. This is a growing concern that we see everywhere.
Mm-hmm. Absolutely, I echo that.
Yeah. Another one is multi-tenancy, right? Both in the public and the private cloud, serving a variety of workloads and applications and users, right? In order for you to disaggregate storage from compute efficiently, we must share the system between these tenants and workloads with a proper isolation in place.
Absolutely, for sure. Yeah.
And another one is, of course, scalability, right? The days of, forklift upgrades, they cannot exist anymore. Storage needs to be able to expand across generations of hardware on demand and always keep the system available and balanced. So, when you need to add more capacity, you either add more drives to the node or expand the cluster with dropping in more nodes, and from there the system should sort of take care of itself. This is a unique benefit to storage disaggregation, right? As you scale storage and compute independently, depends on what you need, right?
Yes.
Next, software defined, right? The modern practice of how to build the cloud that tells us that, we need to standardize on commodity off-the-shelf hardware and have it managed all by software, right? This is primarily true for storage, especially in a post-COVID world, right? Where supply chains has disrupted your safest bet is to rely on commodity components and servers that are least susceptible for disruptions, right? And last, but absolutely not least, is high performance and low latency, right? As you alluded to, Dan, performance is no longer something that we can compromise on, right? We're seeing both networking and SSD hardware. Both of them are changing what's possible with storage performance. And we cannot afford to have all this performance stranded behind a dual controller architecture or any type of legacy interfaces anymore.
For sure.
This is a thing of the past today, right? And all of these are some of the principles that led us, Lightbits, to design our storage solution, right? An enterprise class, high performance, scale out software-defined storage.
Yeah, I think you nailed the essential attributes there, Sagi. Now, you mentioned the storage interface, but what else can we say about such interfaces in terms of performance and latency?
Well, Dan, today we can say a lot. We're in the midst of Flash taking over the data center, for a number of years now.
For sure,
and, in the center of that stands NVMe, which is replacing, SATA and SAS everywhere. Right? NVMe provides you superior performance and latency because it's really efficient. And it's extremely parallel as well. We're no longer constrained by serial storage access like the SATA days. And in recent years, NVMe has grown beyond being locally attached to a server to storage that's attached over different network fabrics, and that is NVMe over fabrics.
Right.
And NVMe over fabrics includes various transports. Like today, we're talking about traditional fiber channel, RDMA networks, and good old TCP. Right. That's also known as NVMe over TCP.
NVMe over TCP. Right.
Yeah.
It's getting to the heart of what we're talking about now.
Yeah. And NVMe over TCP essentially is a transport that defines how we talk to an NVMe device on top of a ubiquitous TCP/IP network.
Right.
Today, it has an established ecosystem natively supported in all of Linux-based distributions and VMware. And the power of it is that it inherits all the goodness of NVMe with all the parallelism and efficiency, but it leverages the most common transport on the planet, right? This all results in a pretty unique combination of high performance and ease of use, right? It's easy to adopt and deploy and manage at scale, right?
Certainly my experience, yeah.
with iSCSI, we're limited in performance to say 10 gigabits on a good day. With NVMe over TCP, we have no problem saturating 100 gigabit interfaces, links, and and beyond.
Right.
With very good latencies at higher loads, and it really, truly delivers performance that is superior compared to these legacy interfaces.
It's great that over the same networks, NVMe over TCP with its parallel nature blows iSCSI out of the water. And Sagi, I've been watching NVMe over TCP evolve for a number of years now. But now I'm feeling that it's really making serious strides forward in terms of mainstream adoption. Especially now that we have VMware supporting it natively, and the leading vendors gradually adding NVMe over TCP support to their storage product offerings. I think that this new protocol is positioned to take over for sure. So let's dig a little deeper into how such storage performance, scalability, and efficiency can benefit a cloud environment. Sagi, what's your take on that?
Well, the first obvious one will be a dramatic bandwidth increase. With NVMe over TCP being a parallel multi-queue interface, it spans across multiple routes and fully saturate a high-speed Ethernet network. And today, the Lightbits solution runs on 200 gigabit interface today per node and scale horizontally and linearly to multi-terabit levels. Second is latency, right? NVMe is very efficient, as we already said. And nowadays, modern TCP IP stacks are much more efficient than they used to be over a decade ago. We're seeing end-to-end NVMe over TCP latencies of under 250 microseconds on VMware with a full virtualization stack between that, and less than 150 microseconds on bare metal Linux host. That's a dramatic improvement for customers that see that every day with us for their analytics and I/O intensive workloads. Third is density, right? Being able to deliver such high performance allows us to build very dense and cost-effective solutions with our customers, right? While traditionally HCI or scale-out software-defined systems could not populate nodes with such high capacity without paying a massive tax, we absolutely support these high densities. And we provide a number of data protection schemes that allows us to limit the blast radius. And we do that by doing software RAID and volume mirroring in a way that allows us to really scale and make a cost-effective solutions with our customers.
So one of the issues that I've come across with high-capacity nodes is long rebuild times. Okay, these can sometimes be measured in weeks or certainly multiple days. Sagi, what is the impact of these high-density nodes that you were telling us about on recovery times?
Well, first we employ multiple data protection schemes, right? We have both local RAID and volume mirroring, and the result is that rebuilds are also faster, right? We have such high performance available in the cluster, we leverage that for faster and higher throughput rebuilds. And in addition, we employ techniques to parallelize and distribute the rebuild and reprotection across the cluster such that the cluster expands, it gets even more available. All that means that even with high densities, rebuilds can complete in minutes to hours. And the important thing is that all of this is completely transparent to workloads. They're consuming storage, they just see NVMe device that's always there, always available, and always high performant. And we have customers that specifically chose us to do this differentiation.
Absolutely. So enabling high capacity per node without the long rebuild time penalty is a real differentiator. Going from weeks or days of rebuild time to go back to full high availability, to now what you're saying, minutes or maybe hours, that's a major differentiator. Yeah,
absolutely,
for sure.
Absolutely. So Dan, you've actually got to deploy this stuff in the field, right? Tell me, how did that go for you?
Yeah, that's right. So just last year, 2021, one of my clients approached me to architect and build a greenfield data analytics system inside a telecoms corporate data center. And we had to deal with very, very large data sets that needed to be processed at very high speeds. And I didn't know how we would actually be able to deliver such performance with the technologies that I knew about at the time. And in addition to the high performance requirement, another requirement was that the analytics system be VMware based. Okay, the whole environment needed to be based around VMware. Now, my experience with iSCSI SANs told me that we simply would not meet the performance requirements. And while Fibre Channel may have initially met our performance goals, it actually didn't meet several other criteria, including cost and the complexity of supporting a Fibre Channel infrastructure. And as we began to look at new vendor offerings based on NVMe over Fabric, RDMA, and also NVMe over TCP, we came across your company, Lightbits, which I'd actually not heard of before then.
Well, I hope you do now.
I'm now well aware. So as you know, your product made our shortlist, and we received really good references from some of your existing customers who were already running Lightbits technologies in production. And we were actually really impressed by your technical team's deep expertise on NVMe over TCP, and also the enterprise capabilities actually in the product already. And honestly, the fact that it was Lightbits who had partnered with VMware over the development and integration of NVMe over TCP into VMware's ESXi was really reassuring to us and definitely an influencing factor.
Absolutely, the partnership with VMware really broadened the market in terms of adopting NVMe over TCP as a new technology, and also Lightbits technology that's built using this new interface. So what happened next?
Right, so we ran a proof of concept, which was thankfully smooth and successful. We certainly validated the native NVMe over TCP support within ESXi, along with the excellent storage performance that we were hoping to see with this new protocol. We consistently see around 250 microseconds application latency, whereas prior SAN solutions that I've deployed have never achieved below 1.5 milliseconds for such I/O intensive workloads.
Analytics are the most difficult ones usually.
Right, it was tricky, and we had to test it. And the fact that the Lightbits solution ticked most of our boxes, plus the proof that we found in the value of NVMe over TCP, just this sheer speed advantage, led us to decide to become early adopters, as you are aware, Sagi. And this really paid off in terms of results. And actually, we moved this system into production at the beginning of 2022. So, in fact, now that I've seen NVMe over TCP network storage working in production with my own eyes and the eyes of my team, it would actually be difficult for me to justify implementing an iSCSI or Fibre Channel SAN for most new environments that I can think of. So I see the Lightbits product as widely applicable to such a large variety of use cases, not just the analytics environment that we built. But now, many leading storage vendors, as you're aware, are busy working on adding NVMe over TCP support to their existing storage products and new products that they're coming out. So the way I see it, the advent of broad support for NVMe over TCP, coupled with its sub 250 microsecond latency, changes the game.
So you're a believer now?
I'm becoming a believer, that's for sure. All the evidence, the empirical evidence that my team and I have done really shows the bottom line, it works, and it's simpler.
Great. So then, we discussed the cloud builders and their needs and storage. Let's shift gears. Let's talk about the public cloud. right? Where do you see public cloud customers meeting their challenges?
So there are a number of areas where I see challenges with block storage in the public cloud, which is what we're talking about. First, there's a massively high cost associated with high performance block storage. Mm-hmm. And you're pretty much locked into using that public cloud's storage options currently. Second, it's a shared infrastructure that you have no control over. And thirdly, there are zero storage efficiencies that we can gain with the public cloud storage native services. It's like thin provisioning or dedupe or compression. So third-party services are starting to become available, but you're not really going to get high performance from those.
I agree. In the cloud, you provision a volume, you give it a capacity, you pay for it. Right? There are absolutely no gains to be made from storage efficiency, thin provisioning, data reduction.
Right.
You pay for it, and
that's what you get.
That's what you get. And today I also think that enterprises have generally a multi-cloud strategy, right? Whether it's on private clouds or co-locations, edge, or the public clouds, they want to avoid a particular cloud lock-in.
Sure.
Or they want to enable burst capabilities on different points of presence.
Redundancy.
Exactly.
Yeah.
And so having a consistent management approach becomes really important here, also when it comes to storage, right? Mm-hmm. And I would add that the future is evolving in an overall multi-cloud trajectory, right? Workloads, we're going to see them move between clouds more and more. So having a single storage system that can bridge between these clouds is instrumental when we think about it today.
Yeah.
And luckily we designed our storage product for the cloud, right? So it only fits that we would have a public cloud offering as well. And today we do on AWS and more clouds moving forward.
So this is really interesting, Sagi. I've seen some announcement recently on my LinkedIn feed, but I haven't really had a chance to really look into this. Can you tell me a little bit about Lightbit's new storage product for public clouds? Where would it make sense to use it, and how much money would it save me?
So today Lightbits has a marketplace solution that allows customers to deploy dedicated Lightbits clusters on demand, on their account, on their virtual private cloud data center. Mm-hmm. And this would fit absolutely great where you have I/O intensive workloads like SQL, HANA, mm-hmm. or Kafka, things like that. Analytics workloads.
Right.
And having a dedicated enterprise class high performance storage running on the cloud, on the public cloud itself, consuming native compute, NVMe, and high-speed networking.
Okay.
That can yield significant cost reductions. I'm talking about up to 10x reductions for high-end workloads like databases that really needs these high performance.
Wow, 10x? That's amazing. Are you referring to the storage cost?
Well, yeah. Compared to EBS, GP3 and IO2,
right.
And that really depends on the workload. But when we look at the entire workload infrastructure, including the database or the application itself, we're seeing overall TCO reduction of 2x to 3x, depending on the use case. Our solution is based on NVMe over TCP, and as we mentioned, right. It can easily be deployed and managed on the cloud natively,
right.
And deliver pretty compelling price performance, in addition to enterprise class services, availability, and resiliency.
So I can both improve my storage performance and lower my public cloud costs? Sounds great. But what's the catch? What's the compromise for these 10x gains that you say Lightbits delivers?
Well, a marketplace storage service that is third party will always involve slightly more steps to configure than the native services when it comes to attaching volumes to instances.
Right.
But that comes with a massive cost that you would need to pay for something like EBS, especially for high performance storage. The reason for these high costs is, the way I see it, is little to no competition in this space. This is exactly where we come in, deliver great price performance benefits and also get the benefits of enterprise features, efficiency, resiliency, and soon we're going to be on any cloud.
Okay, I think I understand. So you're talking about using the native infrastructure of the public cloud, so their servers and the NVMe local drives inside Amazon's EC2 instances, and creating a cluster from those servers to actually offer a Lightbits solution.
Exactly.
Running NVMe over their high-speed networks. Oh, that's excellent.
Plus additional services behind the scenes for stuff like backup and networking aspects. But absolutely, you're correct.
Got it. Okay, that makes great sense. Hang on, is there a minimum volume size when deploying a Lightbits solution on AWS?
Well, no minimum volume size. The minimum cluster size would be sort of 4 terabytes. I think in the smallest instances that we support.
Okay, and how long would it take me to actually set up a Lightbits cluster on AWS?
Well, from the marketplace, once you click all the options, it takes, less than 10 minutes to have a cluster fully ready to operate and store data.
So if I'm able to reduce much of my high-performance cloud storage costs by 10x, plus improve performance, right?
Dramatically.
With no downside, that certainly seems like a game changer.
Absolutely. That's what we think.
Wow. Sagi, this has been really interesting and informative, but we do need to wrap up. We've covered how NVMe and Lightbits are really moving the needle, actually have moved the needle. My team and I have deployed your system in production, and we see the tangible results that you promised us. And so for us, the proof of the pudding, we have eaten. So this has been great. In terms of in next level storage performance improvements while lowering costs and with a low barrier of entry. Thanks, Sagi, for sitting with me.
That was very interesting conversation. It was great to chat, and thank you. Great talking with you today.
Fantastic.